1 minute. Yeah, write 3, it is a byte level striping with a dedicated party. Write 3 enhance fault tolerance by employing byte level striping across multiple drives and storing party information on a dedicated party drive. This configuration is suitable for workloads requiring high throughput for sequential data but is less efficient for random IO operations. Here we have that write 3 concept how we are implementing here. For example, disk 0, disk 1, disk 2 and disk 3. In the disk 3 we have combination of disk 1, disk 0, disk 1 and disk 2 are stored. What is the major concept here implemented? It is data can be transferred in bulk in the disk 3. Then data can be accessed in parallel also, it is possible. What is the major limitation? It requires an additional drive for party. Then in case of small size files, it performs slowly. So we have a very small size in files means it is it's again it will slow process and it is very difficult to retrieve the information. Major concept, what is the major concept implemented in the RAID 3? It is suitable for workloads requiring high throughput for sequential data but is less efficient for random IO operation. What will happen here when we are storing, we have a huge volume of data. In the huge volume of data will be based on the workload process of activities. It will sequentially delivering the information to the user or the employee or employer means high throughput it needed. Each and every people, for example, let us take an example of railway site. In that site, people are frequently they are accessing that particular website for checking and their confirmation and every process of activities they are started using that particular website. At that time, if that site will not give the proper response means it will give the very difficult to user level. So this type of throughput will be sequential data but is less efficient for random IO operation. So random IO operation it is not possible, but sequential and high workload process will be implemented. So it will give the right solution for the user level. So byte level striping with the dedicated party where we need to implement means high volume of data we are handling. Users are each and every milliseconds the user started using that particular site or database means definitely it is we follow try to implement the write 3 concept. Then write 4 block level striping with the dedicated party. Block level striping across multiple disks combined with the dedicated party disk to provide fault tolerance. Here data is written in blocks and a separate disk stores party information calculated by XOR functions. This setup allows for data recovery in case of single disk failure means we will easily retrieve the data, then making RAID 4 more reliable than RAID 0 but less efficient in write intensive scenario due to reliance on a dedicated party disk. Here we see C1, C2, C3, C4 and party. Then C1 it stores 3 zeros and C4 it stores 1 and party it is 1. Then 0 1 0 1 like that or 1 0 0. Benefit it helps reconstructing the data if at most one data is lost. Limitation it can't help reconstructing data when more than one is lost. The benefit and limitation more or less similar because what we are doing, we are losing some information in our database. We try to reconstruct the particular database or information. uh, if only one data is lost means it is possible to retrieve the particular information, but reconstructing data when more than one means it is not possible. So it is the major constraint. If it is one means it is easy to get it, but if it is more than one means it is not possible to get in the RAID 4. RAID 5 by distributing party information across all disks instead of storing in one dedicated party drive. What we are doing, we are distributed the party, significantly improves the write performance, especially for random write operations, because we are going to that information will be going to write in the disk in randomly. For example, CCTV footage, we will take it as consideration for this type of write file. While maintaining fault tolerance for a single disk failure, write file is one of the most commonly used for write configuration due to its balance between reliability, performance, and storage efficiency. Benefit: data can be reconstructed using party bits. It makes the performance better. Then its technology is complex and extra space is required. If both disks get damaged, data will be lost forever. But what will happen in CCTV and footage? Whenever the object is detected, then it will record. Otherwise, it will not record. We have various places it is possible to fix the CCTV camera. With the help of that, we will try to reconstruct the information also. So this is the concept we implemented in the RAID 5. RAID 6 is an advanced version of RAID 5 that provides enhanced fault tolerance by introducing double distributed party. This allows RAID 6 to recover from the failure of two disks simultaneously. Two disks it is failed, making it more reliable for critical system with a larger array. However, the added party calculations can impact write performance. RAID 6, disk 1, disk 2, disk 3. One disk is failed, with the thing of other disk, it is possible we try to retrieve the information. For example, disk 1 A1 B1, disk 2 it is B1, and disk 3 is PB1 and process P1, and disk 4 is PB1, A2 PB2, like that. Different combinations of process we are implemented here and try to retrieve the information. Very high data accessibility it is possible, it is the best benefit. Fast read data translation, we will fastly read the data and we will try to get the information. Due to double party, it has slow write data transaction. Then extra space is required. Majorly it takes huge space concept. Thank you.